Bismillahir Rahmanir Rahim. So we're going to start off, inshallah, giving the breakdown of these binoculars and pretty much give the explanation of how it works and the contraption on the inside with the prisms and so forth. So before I start off the breakdown, I just wanted to show you basically that these are just your normal, ordinary binoculars that a person would use for the telescope or binocular optical aid masla of sighting hilal. So here I want to show you first, bring it in, zooming it in close to the camera, that it definitely is a working binocular. It has that zoom feature that when I put it here close, you can see through the trees outside in the backyard. And then when we move it away, it's just your ordinary pair of normal binoculars. So now, inshallah, we're going to begin to dismantle the binoculars and look inside at all the fundamental parts. First, we're going to remove the two lenses that are the outer lenses. And this is what they pretty much look like. That's one of the lenses here. And this is the glass on the inside. This is a magnifying lens. And I'll remove that as well so you can see what that looks like. Basically, you can remove the top layer. And then remove the washer. And this is pretty much the convex lens, which is like a magnifying glass. When you kind of look through it, just like as you would as an ordinary magnifying glass, that's pretty much what this is. So after having removed that particular lens here, the magnifying glass, which you can see it basically does the same job that a normal magnifying glass would do, takes my finger and just magnifies the object. So this is the first lens that we see, and this is pretty much the function of it. And then when we look inside the housing, that right there is basically the prism that we're talking about in the paper. And the prism basically functions just like a mirror would. It reflects the image. And in reality, there's two prisms inside, and slowly we're going to take a look inside at how the two prisms work together. But the interesting part is that when you look at a binocular, if we look at it this way, this is the eyepiece right here. So normally within the eyepiece, what you'll have is, if you have a direct line of sight, the eyepiece, if you're looking through the eyepiece, your nazar should come right over here. But when you look at the binoculars, it's blocked off and black over here. So following this trajectory of sight, ideally we should just be seeing black over here, right? And the same thing on this side, when we look through the eyepiece over here, well, the cover is off now, but if we had the cover back on, our eyesight should be hitting the back of this black cover piece and so forth. So what is exactly happening over here is that the prism is causing that reflection. So your eyesight is going over here, and this prism is actually bouncing it down over here, and there's another prism back here which then reflects it for a second time over here. So there's actually a zigzag. I'm talking about it from the angle of your eyesight, but if you're to discuss it about how the light comes in through the lens, normally the moon or the object is going to be over here, and the light is going to bounce off of that object and enter into this initial magnifying lens. Those rays are going to travel back here, and there is no eyepiece over here, but there is the prism and there is the reflection created of the image here. This one then channels it over here, and the second prism channels it as a second image, as a second reflection, then down to the eyepiece over here. So you basically have not one reflection, but two reflections. And this is how we're trying to explain as we take apart these binocular sets. And as you can see, that's what's pretty much inside right now. We can see one of the prisms, and the second one is actually back here. If I can just show it to you 1 second. So this is the first prism right here. It's triangular in shape, it's glass shaped, and you're going to see it like that. The second prism, the lens of which is back there, where you can see that light shining over there. The second prism is back there. So when we move that closer, what you can actually see is a reflection of the light. If I could maybe move the camera around away from the light, you would actually begin to see that some illusion is taking place, that you are seeing through that particular prism. But when you look over here, it's blocked off. So the illusion is created that you're seeing through it. But what are you seeing? It's supposed to be blocked off over here. When we bring it back this way, and then you look through, it's as if you're seeing through. Let me get the zoom or the focus just right. Now it seems as if you're seeing through it onto the table. And if I move it around, as you can see the remainder of the living room. But like we mentioned before, how is that even possible if it's supposed to be blocked off? So pretty much the way that that works is through the functioning of these prisms, and it's basically reflecting the image. So like we mentioned before, as this comes here, this reflects the image onto that one, which then reflects it onto this way. And slowly we're going to start removing more of these pieces so you can see the actual inner workings. Okay, so now I'm going to remove the other side lens. And you'll see that pretty much it's the same setup on the inside. And this is, again, the magnifying lens. A binoculars really is just basically two telescopes put side by side. So there's a prism on the other side, there's a prism on this side, and the prisms are held together in place. This is also the other side, which is the second magnifying lens, which is going to magnify the image that is created here in this tube. So when we begin to remove this cover, and this is basically where the other magnifying lens is, and this is the bigger of the two magnifying glasses. This is a much stronger magnifying lens, and what it basically does is that prism reflection that you can see inside there, this lens is going to magnify the image that is being cast on to that prism screen that's inside this particular housing. So this is, again, just a magnifying glass, but you can see it magnifies. Even right now you can see a bit of a distortion because it's showing an inverted image. So this does two things. It magnifies it, and it also re-inverts the image. So if you can see, my fingers are here and it's coming from the bottom, but there it's coming from the top. So there's an inversion of the image as well. So this glass, its function is two. It basically magnifies and it also inverts the image. So that's the two lenses that we've seen so far, and the rest is basically the work of the prism. And the purpose of the prism is not magnification. The purpose of the prism really is just only to reflect the image, like we've mentioned earlier. So I'm going to go ahead and begin to remove these prisms from the inside of the housing. So I just basically remove this black cover, and then you can get a better vision of the inside. And let's start to remove this prism. We have to remove this middle piece. And then the prism is basically this triangular shaped glass, which we'll discuss later, how this prism functions. It's basically like a mirror, and I'm not sure if you can see it just reflects off the back of this side of the glass and this side of the glass. It creates a 45-degree reflection, and technically a refraction, but a refraction that causes a reflection. So this is the prism, and we're going to run some tests to show how the two together create a double reflection. And then you can see still the other side of the prism on this side, right? So it's basically this side from the triangle put this way, and this one was put that way, or rather this way. So later on I'm going to show you the example that in this housing it was put this way, and then the other one is placed this way. Once the prism comes out, I'll show you a diagram of how it would look like and pretty much how it does the double reflection. We'll remove this piece, and we'll continue on to move this piece. So these are basically the two magnifying and erecting lenses when you put together. This is part of a binocular. And the purpose of these two, again, is just to create the final magnification of the image that you're seeing in the tube of the binoculars. And also it erects the image from upside down to right side up. So that's the function of this piece. Now when we look here, we can actually take the binoculars apart, and they become like one telescope and a second telescope, and you put the two together. So here, once we remove this cover, you can see then the second prism, which is this way here, like you had mentioned earlier. Basically how it functions is that this prism sits in upright this way, and then the second prism sits this way, right? So it's a reflection of a reflection. If I have to show you, this prism will then sit this way, like this, right? 90-degree angles. Like this. So this one is horizontal and the other one is vertical. So there's one hole, there's a second hole, and all this does is that the light that comes in from the hole on the left, it gets brought in and then channeled on the hole to the right. When that image gets sent over here to the circle on the right, then as that light comes to the top one, it then gets reverted and channeled to the bottom one. So to give you an example over here, if light is coming through here, or an image, for example, of the moon is coming into here, what the prism does is that it takes it from here and then redirects it and reflects it into that hole over here. So it's coming from this side and then it's going out back to that side. That's the first reflection. Then what happens is that when that image is reflected to this side, then the second prism, it takes this image, which is going out through here, redirecting it back this way, and when this comes here, then we see it through our eyepiece down here. So it is a double reflection created by these prisms, which work like mirrors. And inshallah, I'm going to show you how these prisms create a reflection, basically. I guess before doing that, I actually wanted to show you inside the housing what it would actually look like. So if the prism is set this way in the horizontal, then the next prism is going to be set vertical. So there's basically, each prism has two sides, as you can see that line in the middle, cut at a 45-degree angle. There's a side on the left and then there's a side on the right. So whichever image comes in to this side is going to be sent through, reflected off of here. The image will come here, bounce here, and then get emitted back this way from this side over here. So it comes this way, bounces off, and comes back this way. When it comes back down that way, now the same thing happens over here, that between here, the image then enters into this side of this prism because it's situated like this. So then what happens is, as that image from the other prism comes and enters into this bottom segment, the sight will come in here, it gets reflected here, and then off back this way, and then that's where pretty much our eyepiece comes in and magnifies what it's seeing over here. The image that is created off this prism, then that is what we're actually seeing here at the end eyepiece with this magnifying glass, and then this is magnified image of that which is created on this screen of this prism. Okay, so here in this clip, to show you how the mirror works, let me just clean this lens a little bit. So we have to clean all sides of the lens, all three sides. So this is a yellow straw that I have here, and just so you can get an idea, a little bit, you can even see my reflection in the back. That's my topi over there. So here, as I bring the straw, you can see the reflection off the prism in my hand here. But what you'll notice again is that there is in a gas, which is not just a reflection, but an inversion as well. So as I'm moving this straw from the right side of the lens to the left side, you're going to see it opposite side inside here. I'm touching the left part of the glass, but it's creating the thing as if it's on the right side. Now when I touch it on the right side, it's creating the illusion that's on the left side. So there's an inverse. So the prisms do have this issue. Now when you double up the prism and then you use the correcting lens, that gets solved by the other lenses. So as I bring it closer, you can kind of see what we're talking about, how it creates a reflection. And there's no mirror here, it's just glass. It's cut at a 45-degree angle, and that's what it pretty much does. So when an image comes in through this piece of the prism, like I mentioned earlier, like here, the straw, it's creating an image. It's coming through this side. But what the prism is doing is that you're not going to see a reflection like a mirror here on this side where I touch it. But what it's doing is that the light rays are being bounced off of here as I'm touching it. And then it's being reflected here off of this pane. And then you're going to see it on this side of the prism, like how I'm doing here. I'm touching this side. My finger is on this side. But on the reflection, it's showing up on the inverse side, and that's what prisms pretty much do. Now, this image that you see on the flip side of my finger or of the straw, then what happens is that particular image from here, when I put it on this prism, it's going to do the similar type of reflection. Imagine now if I'm touching the straw on this side, it projects onto this side, and then that projection, because it's so clear, then gets bounced off the mirror basically now the third time, because in reality there's four. First is the light penetrating this side, which then gets inverted over here, and that's a second. Then the third one from this gets cast onto this prism over here as if this was the image, and then it comes for the fourth reflection to come off to the eyepiece over here. And that's pretty much how the prisms work. And I'm going to give you another display through the use of a laser that will represent pretty much something very similar, because the way how sight works is that we have a light source. The light that I have on in this particular living room, or the light from the sun outside, the light shines onto objects, and these objects give off light in all different directions. What the prism does is that it catches that light or in the case of the binoculars or the telescopes, it catches those light rays in through the lens, and then it begins to reflect and to refract that light in different directions until finally we get the images that we see. But it all creates the illusion that we're seeing through it. In reality, we're not seeing through it. We're actually seeing an image caused by 4 reflections, right? So you can see that.